Continuing with our lesson on 8-5, but we're now going to solve quadratic equations using the square root method. Okay, square root. Now, just to recap, square root means this, like square root of 16 would be 4. Okay, you're looking for what number times itself that gives you 16. Now, we're going to learn something here when we have x squared. So when we have x squared, let's just do this. X squared equals 16. If I have it written like this, well, what number times itself gives you 16? Well, 4 does. But when it's written like this, there's another number besides 4, negative 4. So this one would actually be a positive negative 4, meaning there's a positive 4 and a negative 4 that will make this statement true. If it's written just like this, square root of 16, we're assuming the positive root. But in this case, now we want the negative and positive root, meaning this is setting us up for all of this. What that means is it would cross at the negative 4 and the positive 4. Okay, so depending on the A term, it either open down or open up, but either way, it would cross the x-axis at the positive 4 and negative 4. So when we see equations written like this, ax squared plus c equals 0, meaning when there's no bx term, we could probably look at it and see if it's a perfect square, and we talk about square roots. So when that happens, really we have the difference of perfect squares, which you guys actually solved this in chapter 7. You factored this already, and I'm going to show you 2 ways. This way, if you notice, you have square root minus 49 equals 0. Well, what we can do there is we can add 49 to each side and get x squared equals 49. Well, what number times itself gives you 49? That's going to be 7 and negative 7. So in this case, our roots are going to be 7 and negative 7. In chapter 7, I'm trying to think of difference of squares. I think it was like 7, 7 or 7, 8. Maybe 7, 8. You actually solved this way. You said, well, that's if x squared minus 49, that's going to be x plus 7, x minus 7. We could make that equal to 0, which we'll be doing here shortly in Unit 8. And then solving for each of these, and that's going to be 7 and negative 7. So we will get to that factoring again, like we did in chapter 7. But in this case, when it's perfect squares, this is actually a little bit easier. All right, so let's do this one. X squared minus 16. Well, that's perfect square. That's a perfect square. We're going to add 16. So you have x squared equals 16, and I did that example up here. So your 2 solutions are going to be a positive 4 and a negative 4. You might write it like this, or you might write it like this. And it doesn't matter if you have the positive first or the negative. Now, this is the set notation. If you did parentheses, that looks like an ordered pair. So be careful there. Okay. Now, all right, let's look at this one. If we do the same thing, we have x squared. Now, this is a plus 25. But if we subtract 25, we get x squared equals a negative 25. Well, what number times itself gives you a negative 25? Now be careful, because if we did the square root of both of these, is there any number times itself that gives you a negative? Okay, this is not possible. This is not possible. So this is going to be, you can't have a negative inside the radical sign. So this is going to be a no solution. You might even see it like this, an empty set, which means no solution. All right, let's see about this one. Now we have 4d squared plus 16 equals 16. Well, if we subtract 16, that would be 0. So we have 4d squared equals 0. Well, divide by 4, d squared equals 0. Well, what times itself gives you 0? That is just going to be 0. So I've seen people do this, but you really don't need that because there's not really a positive or negative 0. It's just 0. So which means there's one solution. And then that vertex is hitting at the 0. So that's 0, 0. So 0 is your solution. Okay. All right, let's try this one. Subtract 11, subtract 11. Negative 5x squared equals 5 divided by 5x. Now this is going to be a negative 1. But what number times itself gives you a negative 1? There's nothing. So this is another no solution. You cannot have a negative in the radical sign if it's a square root. Now if it's a 3 in the index, you can do that. But this is going to be a no solution. Okay, so x is going to be an empty set. Okay, so this is one way to solve using the square root method, that if they're perfect squares like that, you can bring that to the other side and then solve it. And sometimes it's harder to see it in problems. So we're going to actually look at other ways to solve these in our next few sections. Okay, there you go. There's how to do the square root method.